Algebra 1. Today we are going to start really talking about this word right there. It's a word that confuses algebra students all the time. So I'm hoping that we can really work through what that word means because it does not go away. That word function is going to hit you in algebra, algebra 2, pre-calculus, etc. So let's focus in and see if we can figure it out. So first of all, match each picture to the correct word by drawing an arrow from the word to the picture. So from the word to the picture. From the word to the picture. From the word to the picture. And from the word to the picture. Okay? Now I was really clear. I asked you to draw a line from the word to the picture. Now, you may have naturally matched the pictures with the words, and there are certainly other ways to pair the pictures and words. For example, I could match the pictures to the words left to right, then top to bottom. I could go, the first one on the left is a polar bear. I could match first with first, second with second, third with third, fourth with fourth, etc. Like I could match these very differently. I could group them anyway. But because I asked you to go from picture to word, that is, I did that on purpose. So this really simple example, I'm trying to build the concept of a function in your head. So there's always going to be a set of inputs. I'll write that down. We're always going to have a set of inputs, which is called our domain, matching a set of outputs, which is called our range. Okay, those are all very important words. And that's always according to some type of criteria. So as we work through these lessons, we're going to slowly introduce algebra to it. Right now we're talking about animals and names, right? We're going to learn that by substituting every value in the domain or input of a function into all the instances of the variable in the algebra, and then we're going to evaluate or do some math, we're going to determine if the function is associated with each x. That was a lot of words. I know. It's okay. Little more discussion. I know you're staring at this page going, what else is she going to talk about? Well, let's do our definition first, and then I'll push you a little bit more. So I have a function. A function, I've always said it's a name. I can write it like this, is a correspondence between two sets. Sorry, my nose is running. A correspondence between two sets, big X and big Y, in which each element of X is matched to one and only one element of Y. The set X is called the domain. The set Y is called the range. Pause there for a second. So what we just talked about is element of X. So this box of words right here is big X. It's all of the elements of X. There's 4 elements of X. And we're matching them 1 to 1 and only one element of Y. So this right here is our big Y. It's our elements of Y, and there's 4 of them. And I was able to match just 1 to 1, right? Just 1 to 1. So each element to X is matched or is in correspondence to each element of Y. This notation, F, such that X goes to Y, that colon is called such that. Very fancy, I know. The notation f such that x corresponds to y is used to name the function and describes both the set x and y. If little x is an element in the domain x, so I've got little x here, these are all little x's. Oh, I'm still highlighting, sorry. Those are all little x's. So if little x is an element in the domain big X of a function f such that x goes to y, then x is matched to an element of big Y called f of x. Whew. We say f of x is the value in y that denotes the output or image of f corresponding to the input x. So y is your output, your range, x is your input. Alrighty, so the range or image, we'll get to the word image later, but the range of a function f such that x goes to y is the subset of y, denoted f of x, defined by the following property. Y is an element of f of x if and only if there is an x, little x in big X, such that f equals y. All right, so what that last, sentence? 2 sentences? 1 sentence. What that last sentence means, like, don't lose me here. Like, stay focused in. I've got f such that the set of x goes to y, corresponds to y. So the range is a subset of y. It's a piece of y. It's parts of y. So I've got y is an element of f of big X if and only if there's a little x in big X, where if I plugged in that little x, I get y. That might make sense more. That might make better sense with an example. That slide took 7 minutes. Whoo, doggy. So define the opening exercise using function notation. State the domain and range. Okay, function notation is very important because that's how I'm going to grade your work, and it needs to be written properly. Think about math just collided with English. It's okay. I've got f, so my function, such that the set of all words listed goes to the set of all animals pictured. And I spelled it wrong. Animal, oh goodness. Animals pictured. That just means we're assigning each name to an animal. So my domain equals the set of the 4 animal pictures. And the range is the set. Actually, I'm going to redo that. I can be much clearer. The domain is the elephant, the words. I said it backwards. I apologize. The words elephant, zebra. I don't believe they're in this order. Camel and bear, polar bear to be exact. And then the range is the 4 animal pictures. Okay, the domain is the set of the words elephant, zebra, camel, and the range is the set of the 4 animal pictures. All right, let's try an example. In the assignment of students to English teachers, is the assignment of students to English teachers an example of a function? If yes, define it using function notation. What I want to remind you here is I always have 1 matched to 1. That is a function. Just like in our previous example, each animal name had one animal picture. So if I think about the domain, if I read the question again, it's going to be all the students in your grade level or class. Not classroom, but your grade level. And then our range is going to be all of the English teachers in your school, right? So my function notation would be F such that the set of students in your class goes to the set of English teachers in your school. And we have the domain and the range. I would just write the domain is the students in class, the range is all of the English teachers, because we're assigning students in the class to the English teacher according to their class schedule. All right, let's talk a little bit about this. I'm going to give you one. What this is we are assigning all people to their biological fathers. The domain is all people. And the range, that's awful. I mean, my handwriting isn't great, but yikes. Range is men who are fathers. So, yeah, we're assigning all people to their biological fathers. Let's see. So, well, let's try this one. What is the meaning of the function evaluated at Tom equals Peter? That means we're assigning Tom to Peter, so Tom is Peter's son, right? What would it mean to say f of Tom equals Tom? Tom is his own son or father? That doesn't work. Doesn't work. Tom can't be his own father, so it's impossible. So what did you really mean? Maybe Tom the second equals Tom the first. Okay. What if Anna's father is George? How could we use that? We would say Anna equals George. Okay, that would be an example. It works well. That makes sense, right? All right, let's move on, make it a little harder. What if we define a new function where we're going to assign fathers to their children? Okay, so my domain is the fathers, the range is the children. Would this be an example of a function? Well, no, because I can't say like the function of, I don't know, my dad's name is Fred equals Carly, because the function Fred also equals Mike, Carly's brother. Because Fred, my domain, goes to two ranges, that doesn't work. It's not a function. It's the definition of what a function is not. Your domain of fathers can be assigned to more than one range of children, and that's a no-no. All right, let's try example 3. I've got let the set X equal the elements 1, 2, 3, 4, and the set Y equal the elements 5, 6, 7, 8, 9. Your functions f and g are defined below. F such that x goes to y. So I've got my x's and my y's, if that makes sense. X matches to y, x matches to y, x matches to y, yada yada. I mean, it's not in order. They're telling you what the function is defined at. Then I've got g, x goes to y. So all of these are your function is defined. So is f a function? If yes, what is the domain and what is the range? If no, explain why. So for this one, we can actually say yes. Why, you might ask? Well, let me tell you. Each element of the domain, this is important, each element of the domain is matched to exactly one element of the range. So my domain is 1, 2, 3, 4, and my range is just 5, 6, and 7 for that particular problem, because I've got 5, 6, and 7. Those are all my numbers I used. If I look at G, no. Oops. It's not a function, because each element of the domain is assigned to more than one element of the range. If I look, I've got the domain of 1 assigned to 5 here and 8 there. That's a no-no. Okay? It's like Fred with Mike and Carly. So for example, 1 is matched to 5 and 8. That's a no-no. What is the function f evaluated at 2? If you look up, 2 matches with 5. So f evaluated at 2 equals 5. If f equals 7, what might x be? So f of x equals 7, we're going to look at the thing, and it looks like x could be either 1 or 4. And that's okay. I can have 7 come from 1 or 4. That's okay. 2 domains going to the same range, but I can't have one domain going to 2 different ranges. So define f. We have a few exercises, sorry. We're going to go through them, and it's a lot like your homework. So define f to assign each student to your school, each student at your school, a unique ID number. So our function notation would look something like the function such that the set of all students in your school goes to the set of all whole numbers. Assign each student a unique ID number. Is this an example of a function? Yes, because every student, they're all different. All students get unique numbers. No student's going to share a number. Suppose the function evaluated at Hilda is 350123. What does that mean? Well, it means that Hilda's unique number is 350123. No one else gets that. Write your name and student ID number using function notation. Okay, so the function evaluated at Carly equals I'm going to say my door code number, but I'm not going to tell you my door code number because that is unique. Every student has their own door code number, okay? Or I could say every student or person has their own email address. Let G assign each student at your school to a grade level. Is this an example of some function notation? Yep. So each student has only one grade level. No one student's going to be in two different grades. I mean, usually, okay? In high school, no. When you go down to the lower grades, you've got some kids that are moving math classes into a higher math level, but it's not what we're talking about. So express this relationship using function notation and state the domain and range. We've got G such that the set of all students in school goes to the set of grade levels. Assign each student to a grade level. So my domain is the students in school, and my range is the grade level. Okay, last one. Let H be the function that assigns each student ID number to a grade level. So I've got H such that the set of all student ID numbers goes to grade levels. We're going to assign each student ID number to the student's current grade level. Describe the domain and range. So that is my domain. Getting a little lazy. Yes, I am. And that is my range. Record several ordered pairs that represent yourself and students in your group or class. I could say C's door code and C. I could say, I don't know, we've got John's door code and John, etc. Johnny says, this is not a function because every 9th grader is assigned the same range value of 9. The range only has 4 numbers. In our school, right now, it has 2 numbers, 9th and 10th. But the domain has a number for every student in school. Explain to Johnny why he is incorrect. Because each student, another student, a third student, I can get my domains assigned to the same range. I can't go backwards, okay? I can get many different domains assigned to the same range, but I cannot assign myself to different grade levels. I can't be in different grade levels at once. I have to be in the same grade level. And no, I'm not going back to high school. Awesome. Good work today. That was a little long.